Hi guys, this is the educator here. Welcome back to my channel. So in today's video, we're going to be looking at MTH102 possible questions. Alright, so in this video, I have designed and structured these questions to contain only theoretical questions. Okay, so just in case after this video, you will need the possible questions for the calculation aspect, then do well to indicate in the comment section. So drop it. Alright, so before this question or this video was done, I created a crash course file where I explained some important concepts and things you need to know about everything you'll be doing in MTH 102. Right, I have about 50 questions here. If you want to use this video to practice or to see how well you are prepared for tomorrow's exam, definitely you can use this video. So what you just need to do is when we move straight to the next question, you can just pause this video, then read the question and then pick your answer before I pick the answer. Alright, so let's move. Question 1. We have a relation from set A to set B is defined as. Alright, so the correct answer to this question is option B. Option B. So we have option B to be the correct answer. The reason is because a relation is a subset of Cartesian products A times B. It is in the material that I sent across. Alright, so just in case you are watching this video and you don't really know about any material, any crash course material, please do well to indicate in the comment section. Okay, so after this video, I'm going to be dropping my WhatsApp number, so just do well to send me a message so that I'm going to send the file to you. Okay, so correct answer is option B. Next question. The total number of relations from a set with m elements to a set with n elements is dash. Whenever you see total number of relation for any question that you be given in your exam, this is the formula here, option C. So 2 to the power of m and then n. So if the relationship from a particular set, m has 3 elements, all right? So let's say m has 3 elements and then n has 2 elements. And it said, what is the total number of relations from these two sets? It will be 3 times 2, that is 6. And then we'll have 2 raised to the power of 6. So you can come across this question like this and they'll tell you the formula or they'll give you the elements, just like I've solved here, the number of elements for you to calculate it. Always remember that this is the answer. So the correct answer is C. So the next question, we have a function is injective if dash. A function is injective if dash. Very simple. A function is injective. It means when a function is injective, it means that function is one-to-one mapping. Alright, when they say one-to-one mapping, it means that one side is corresponding with the other side. They are the same. Alright, so if you look at the options, every element in B has a pre-image, wrong. Every element in A maps to multiple values, wrong. Domain equals range, this is wrong. So the correct answer is option B. Remember, in injective, something happens. There is one-to-one mapping in injective. So that's when you can say, oh, this function is injective. So in that particular file that I've been talking about, I have also explained, giving an example there. So please, you can check it out, okay? Then you should also remember, but let's move straight to the next question. A function is surjective if dash every element in A has no image, wrong. Range equals domain, wrong. Range equals codomain, this is correct. Range is equals to the codomain. Please take note of all these important concepts because if these things come out, it will be a bonus for you because you are seeing it now. Okay, so once you see that the range and the codomain they are the same, then your mind should go to the function is subjective. All right. So moving to the next one, we have a function that is both injective and surjective is called a. This one should not even be so difficult when you see this kind of question. So correct answer is bijective. No time to waste time. Bijective. We move straight to the next question. The inverse of a relationship R is obtained by dash. The inverse of a relationship R is obtained by dash. To get inverse of a relationship, what happens is that we swap coordinates. So correct answer is B. So if I have a relation as X, I have a relation like this. The inverse is going to be Y, X. So what happened here? What happened is that we swap this alphabet. So you can see, so when we swap coordinates, we are getting the inverse of a particular relation. Next question, which of the following is not a function? Which of the following is not a function? One input has multiple outputs. This is correct. So option B is correct. Which of the following is not a function? Option B is not a function. Okay, so a function cannot map one input to multiple outputs. Please take note. A function cannot map one input to multiple outputs. So when we say, let's say we have 1 here, this is the input and this is the output. This one is now mapping here, here, mapping here, mapping here, mapping here. All right, so this is not acceptable. Where this is the input, this part here is the input, and then this part is the output. So every element has an image, is a function. C, many inputs share one output, is also a function. It can be possible. Many inputs share one output. It can be possible. But one input has multiple outputs. This is wrong. The correct answer is option B. One input has multiple outputs. So if we move straight to the next question, question is the function fx is equals to x squared is not injective on R because, remember we said something about injective. Now when it is injective, it means that question is a question that you must take note of. It's more like a note. All right, in your questions or your notes, why they are giving you notes, they'll tell you some important points you need to take note of, and this is one of the important points. When you see something like this, x equals to x squared, this is not subjective because in this particular relation, f minus x equals to fx is not one to one. And remember, injective shows that one to one mapping, right? But this guy here is not one to one. So whenever you see this particular function is not injective, just know that it's because of this, because this is not one to one mapping. Question 9. The limit exists if this is once this kind of question, just know it's a bonus question and you should know what it means. Correct answer is B. So the limit exists if the left hand limit is equal to the right hand limit. This one is a bonus question. Question 10. If the left hand limit is not equal to the right hand limit, it means that the limit does not exist. Right? Remember, because we established in the previous question that for limits to exist, left hand limit must be equal to right hand limit. But then if it is not equal to it, means that the limit does not exist. So the next question. Limit fx plus gx equals to limit fx plus gx is equals to. Correct answer is option B. Please take notes. Please take notes. The limit law, one of the limit laws states that limit of sum is equals to sum of limits. Please take notes. Limit of sums is equals to sums of limits. Correct answer is option B. Alright, let's move to the next question. Question 12. The form 0 over 0 is called. This is also a bonus question. When you see 0 over 0, it means, is it undefined? No, it's not undefined. Is it infinite? It's not infinite. Is it 0? No, it is not 0. It is indeterminate. Indeterminate, because 0 over 0 does not give a definite answer. That is why if your limit, if you solve and your limit is now 0 over 0, please don't stop there. It means that you should continue to simplify further. There is nothing as this. This thing does not determine anything. Alright, so next question. A function is continuous at x is equals to c if a function is continuous as x is equals to c if the function c exists, correct? Limit exists, correct? Limit, once you see two options are already correct, just move straight to your all of the above. All of the above is correct. So these are the conditions that happen for a particular function to be continuous. The function c exists, the limit exists. The limit is also equals to the function value. A removable discontinuity occurs when so remember the previous question we talked about continuity when the function is continuous. Now a removable discontinuity occurs when the limit does not exist. No, the limit exists but function is not defined. This is the answer. So when a limit exists but the function of that limit is not defined, it is discontinuous. Discontinuous. Please take note. Removable discontinuity. Number 15. A vertical asymptote occurs when we have a vertical asymptote and we also have an horizontal asymptote. But as we proceed, there's a question concerning horizontal asymptote also. So a vertical asymptote occurs when the limit is infinite. The limit is infinite. When the limit is infinite, you see that you have a vertical asymptote. Then the next question. The derivative represents, this is also a bonus question, the derivative represents slope, right? That's why you always have dx over dy, right? And this dx over dy normally in graph you have something like change in x. That's what this guy means. So you can have something like this: change in x over change in y, right? And if you have something like this, what is it called? It is known as your slope, known as your gradient. Okay, but you should know the y dx, right? I just use the x dy because I'm trying to explain that derivative has to do with slope, but then you should not forget it is dy dx. You are differentiating in respect to x, so please don't forget that. The next question, question 17. The derivative of a constant is, this is another bonus question. Derivative of a constant is 0. So if we derive, what is the derivative of 4? Derivative of 4 is 0. What is the derivative of 5? Derivative of 5 is 0. Derivative of 6 is 0. Alright, so please take note of that. Constants do not change, and this is one classical trap they always set in exam. Constant does not change. So when you see derivative of constants, just know it is 0. Number 19. Okay, number 18 first, sorry. 18. The chain rule is used for simple functions, no. Products, no. Quotient, no. The chain rule is used for composite functions. Composite functions. So if you see a particular function that looks like this, let me say 3x plus 2 raised to power, let me say 4. What you are going to use to do this differentiation is chain rule, because this function that you are seeing here is a composite function. So please take note of that. So chain rule is used for composite function. Number 19, the product rule is used when, this one is simple. The product rule is used when there is when multiplying function. So when multiplying function, you use the product rule. When dividing functions, you use the quotient rule. So please take note of that. Question 20. A stationary point occurs when the slope is equals to 0. The slope is equals to 0. Stationary point, one place. The slope is equals to 0. So please take note of that. Next question, we have the second derivative is used to determine. So remember that the first derivative is dy over dx, right? Now, that's if you want to represent first derivative, because you can see the question as first derivative, or you can see it as dy dx. Then you can see it as like this. Once you see it like this, you should know that this is the second derivative. So there's a way they can ask this question. They'll just tell you this guy, d square y over dx square, is used to determine what. When you see this, you just know this is second derivative. This is first derivative. Okay, first derivative is dy dx, second derivative is d square y over dx square. All right, now the second derivative is used to determine the concavity. So let's erase this. The second is used to determine the concavity. So concavity. All right, concavity, not area. Please correct that. Concavity, not area. Okay, so now this is what I'm trying to let you know. So let's say we have a particular graph like this. So we have two graphs. For example, we have another graph like this. So the second derivative is used to determine the concavity, this curve. So let me use another color so that you get what I'm doing. So this curve here, this curve, then you have another one. The curve is like this, right? So when you see this kind of thing, just know this is second derivative. The first derivative is used to get the slope. All right, so you know when you want to get slope from a curve, you now do something like this, right? You do something like this. So this slope here is the first derivative, and then the curve, the concavity, is the second derivative. Now there's something that you should put in your mind. If you see u-shaped, u-shaped means minimum. U-shaped means minimum, and minimum is positive. Please take note. So this guy here is positive. So let me use VE, positive. Then when you see N, it means what? Negative. So now you can use it to remember. If you have a face, let me say you have a face like this. So it's either the face is smiling or you have another face that is frowning. Now, if you are smiling, it means positive. If you are frowning, it means negative, right? But now, you should also remember that smiling is minimum and frowning is maximum. This is what you should know about this question, okay? So the next question we have, if second different derivative, right? Second derivative. Remember I told you when you see something like this, you know it's second derivative. Now they said if the second derivative is greater than 0 at a stationary point, the point is now greater than 0. Is it positive or negative? Question is greater than 0. Greater than 0. Please let's correct that. Greater than 0. So if second derivative is greater than 0 is positive, please take note. It is positive, not negative. It is positive. So when it is positive, it is not this guy. When it is positive, we will smile, right? So when it is positive, we are going to what? Smile. And when we smile, the point is what? Minimum. It's as simple as that. So please, all this information, do well to take note of it. If it is greater than 0, that means it's positive. If it's less than 0, it means it is negative, right? 23. You can see the question has come now. If second derivative is less than 0, which means it is negative, right? If it is negative, it means it is frowning, right? And then if it is frowning, what happens? It is what? Maximum. Maximum. So correct answer is maximum. So the next question, 24. Integration is the reverse of, this one is another bonus question. Integration is the reverse of differentiation. So the opposite of integration is differentiation. So let's move to the next question. The constant of integration is added because, so why is it that when we do integration, we always have a constant? We add c, you know, right? We always add c. So the question is, why are we always adding c? Why are we always adding c? Question, the first option says function is incomplete. Is that correct? No. Question, option D says it is optional. Is that correct? No. It is not optional because everywhere we always put c, right? The C says to simplify the result. Is that correct? No. The correct answer is because the derivative of constant is 0. The derivative of constant is 0, which means that for us to get that integration, right? So let's say you are given a question as y square plus, all right, so let's move straight to the next question. 30. A definite integral represents a definite integral. Remember we said the definite integral is a constant. So now, what is it now representing? It is representing the area under, let's move back to the question. 31. 30. It represents the area under the curve. The area under the curve. So if you have a graph, then we have a curve. The area under the curve is represented by your definite integral. Alright. You should take note that this area can be negative. Right? It's not only positive, it can be negative. 31. Next question. If upper and lower limits are equal, the integral is, this is another bonus question. If the upper and lower limits are equal, the integral is 0. The integral is 0. Remember, you will subtract. So if upper is 2, lower is 2, that is 2 minus 2, that is 0. It's as simple as that. 0. 32. Reversing limits changes the sign of integral because reversing limits change the sign of the integral because the direction of the integral reverses. The direction of the integral reverses. So for the next question says, question 33, integrate 0 with respect to x. Remember that if you differentiate something, you will get 0. So what's that thing that if you differentiate, you get 0? C. It's as simple as that. So if we differentiate c, we have 0. The same way if we integrate 0, we are going to have c. That is just how it is. Next question. The derivative of sine x. This is another bonus question. If you see anything derivative and integration relating to trig, is a bonus question. So derivative of sine x is cos x. In that crash course material, everything has been listed there. Cos x. That's for the derivative of cos x is minus sine x. Please take note. 36. The integral of cos x. Remember, sine x will give you cos x. But then now if we are getting the integral, it's the opposite. That's sine x. It's as simple as that. The reverse of integral. The reverse of derivative, sorry. 37. We have integral of sine x is, so the integral of sine x will be minus cos x. Alright, so the next question says 38. A function is even, if you see this question, it's another bonus question. A function is even when the function minus x is equals to x. So when function minus x is equals to x, this is even. You should also know for odd, right? You should also know for odd. Next question, the function is odd if the function minus x is equals to the negative function of x. Please take note. You can see the difference between the odd and even. This is even here. Minus x is equals to x. While in odd, minus x is equals to the negative function of x. Next question, 40. The domain of root x requires the domain of root x. Remember, for us to have root x to be existing, it means that x must be a positive number, right? And for x to be a positive number or 0, except the question says otherwise, it means that a condition must be fulfilled, and that condition is x is greater than or equals to 0. Because you can have square root of 2, you can have square root of 1, but then x less than 0, you cannot have square root of minus 4. What's the square root of minus 4? You end up getting something that does not exist. All real numbers is wrong because minus 4, minus 2, they are all real numbers. So because of that, not all real numbers does not fulfill this particular question. Next question, the domain of 1 over x includes. Okay, exclude. Sorry, the question says exclude. That means which of these will not exist? We can have 1 over 1, right? We can have 1 over 1. We can have 1 over minus 1. We can have 1 over 2. But there's nothing like 1 over 0. So the correct answer is B. We will not see a domain as 1 over 0. There's nothing like this mathematically, right? So moving to the next question, the domain of log x will require, log x will require, remember we can have log 0, we can have log 1, log 2, log 3. But now you should take note that there is strict inequality, and that strict inequality, 0 is not allowed. So we wouldn't have something as log 0. So just because we will not have something as log 0, it means that anything that we are going to have should be greater than 0. So our correct answer is option B. Next question, a composite function means, what is a composite function? Remember I said something about composite function earlier where you use chain rule. Remember, you use chain rule for composite function, you use product rule for multiplying, and use quotient rule for dividing functions. Alright, so composite function now. What is a composite function? Composite function is a function that is inside another function. So when a function is inside another function, it is known as composite function. So you can see something like this, f, then g, then x. This is an example of a composite function. Function inside function. 43. What does this mean? Very, very simple. If you see this question, you know that is a bonus question. It's the same thing as composite function. This is what I wrote in the previous question. This guy here. This is it in another way. So the correct answer to this is C. All right. Next question. A horizontal asymptote. Remember vertical asymptote. Now we have horizontal asymptote here. So horizontal asymptote occurs where x is infinite. Infinity. That's when you have horizontal asymptote. 46. If degree of numerator is greater than denominator, the limit at infinity will be infinity. Question is very simple and straightforward because numerator is greater than denominator. If degrees are equal, limit at infinity is if degree are equal, limit at infinity is ratio of leading coefficients. Please take note. Ratio of leading coefficients. Only leading terms matters, right? So take note, you must ignore lower power. That is not your business. You must ignore lower power. 48. If degree numerator is less than denominator, limit at infinity is zero. It is zero. Why? Denominator grows faster, right? The denominator grows faster and the result tends to zero. As the denominator is growing faster, where is your result going to? Your result is going to what? Zero. But if the numerator is higher, what happens? Your result is going to infinity, right? So please take note of these two. Next question we have a function with left hand limit not equals to right hand limit at a point is discontinuous. Please take note. Discontinuous. Discontinuous. Equal limits. Unequal limits breaks the continuity, right? Equal limits we give continuity. Unequal units we break. Unequal limits rather we break the continuity, and that's where you now have discontinuous limits. And the last question, but not the least, we have the slope of the normal is the negative reciprocal of tangent. Please take note. All of these theoretical questions have been indicated and everything has been explained in that crash course file. All right, so do well to go through that crash course file if you are still going to have time to do that. All right, so please, if you enjoyed this video, please do well to hit the subscribe button and try to subscribe to this channel, okay, so that you are not going to be missing any important updates that has to do with your examinations. All right, so just in case you have not shared this video to somebody, please do well to share it to someone, do well to share it to your friends, share it to your classmates, share it to your departmental group chat, your faculty group chat, so that you are going to be good to people by sharing these updates with them. All right, so I want to wish every one of you who have watched this video resounding success in your exam, depending on whenever you are going to be writing your MTH102 exam. All right, so all the best, and I'm waiting for your testimony. Bye for now, guys.